Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about how to pre-process enums. So if we go back, we are still in our pre-process function. First thing you want to do is create a pre-process enum declaration function. And of course, you want to pass in the branch. So for this function, we want to do some basic things. So we want to set up, or we want to get our block. So we're going to say AST enum identifier list, because if you guys remember in our parser, we have a list of enum identifiers which represent our values. Then we have a list of flags and the current class that's going to represent our enum class. First thing you're going to want to do is parse your class access flags. Now we haven't gone over these, so let's go over this. So in order to parse a class access flag, it's going to be very similar to how we process fields. So before we go into this function, let's just look at the outer code to see what it does. So here, let me close a bunch of these. So if we look, I mean, we can see here that we have the standard like default values for our access flags. If we don't have public, private, or protected, we're going to default the class or this enum declaration to a public. Otherwise, if we don't have any at all, then we're going to default it to public. So with this, it's a class, so we just want to set it to public by default. So let's see what we are going to do for parsing class access flags. So you're going to want to pass in your flags in your current AST. So it doesn't matter. I pass in, or it does matter. I pass in the AST sub AST of access type as the AST because I'm going to have to get the information from this abstract syntax tree. So for classes, we're never going to have more than 4 tokens. So this is just like the last function we saw. There's only a certain limited amount of tokens that you could have. So you're either going to have a public, private, or protected, a local, extension, and a stable. So we're going to do our standard like looping through the list. All we need to do is just convert our string to an access flag, add it to the list, and do some checks. Now for classes, if you have a constant or a static class, that my language doesn't support static classes. So this is something that I was looking to, whoops, this was something that I was looking to support, but it's not that easy to support static classes. So I decided to just not do it at all. So keep that in mind. After that, so we want to say illegal access specifier, and we just say whatever the token is. Otherwise, if the last flag was equal to whatever the flag previous was, or the current flag is equal to whatever the last flag was, then a illegal access declaration duplicate access flag because we don't want the user saying public public. After that, we have flags equal to local and not global. We've seen this before. You can't have local things that aren't in global scope. Okay, so here's how I do flags for classes. Now this one is a bit more involved. It's literally the same code that we had before where I had like my if statement checks and all this weird stuff. So we'll have for classes the first main part and then the second part. And you can see I put like little things here to kind of denote that. So the first part is going to be public, private, or protected. So for this one, because I have a bunch of more access flags, I ended up putting this into an array to make it a lot easier. And then with this matches flag function, and I basically say, here's the flag order, right? Here's the order of the flags. Here's the length of the flag order that we passed in. Here's the starting position of where we are in the order list, and here's the flag. So the idea behind this is you want to basically, all right, so if we're going to start at 3, that means 0, 1, 2, 3. We're starting at local, right? Because if the current flag that we have is less than or equal to protected, that means it's one of these. So if flag size is equal to 2, we're only going to have one of these and then potentially one of these. So the match flag, all it does is it takes the flag list, it takes the length of that list, the starting position, and the flag we have, and just for loops through that list and checks to see if that flag at that starting position or beyond is equal to the current flag that we passed in. The idea behind that is technically speaking, if you have a public, you can have one of these and it doesn't matter which one. So that's kind of why we do it. I think it makes sense. It's just a much cleaner way instead of me having all these weird if checks. So yeah, so I do that. So I say, all right, if we have 2, then the starting position is 3, meaning we start at local and beyond. And we just check to see if the flag is equal to that. Otherwise, if it's not, as you can see here, then we set the error position equal to 1, which is the next index after the current access flag, and we go to the error. Going to the error prints the exact same message that we had before, so I don't have to go over it. We're just saying that we don't know what this access specifier is. Make sure the order is correct. We also have a check here for like, okay, so if we find public or we find the private or protected, and it's a local, then we're going to print out a warning saying basically the local access specifier trumps all of these access flags. Because technically that's true, right? Like the local keyword is literally only going to allow for accessibility to be within that file. So if we say local and then we put private on top of that, that doesn't really make any sense. Um, so we just want to warn the user for that. And I mean, you can kind of see, like, I'll just briefly go through these really quickly. So we have less than or equal to protected. So one of these, so I already did two. Now we have the example where we have three, which means we have one, two, three. So it's going to be two potential secondary candidates. So we're going to start at three, check to see if that flag, and we're going to set the error position to one, by the way. That way, since we know the size is three, we want to start at the next one after the public, private, or protected. So we start at that error position and we just plus it. So we say beyond, basically, if we're going to start at local and say if it's any one of these, and then we're going to push it one more to the start position of stable, and it's either this one or the other one. Before, I do the same thing. I start at 3, which is local, then 4, which is stable, then 5, which is extension. In this way, I can basically just force the compiler to resolve things in the correct order. In my opinion, this is the better way of doing it, but yeah. So if all of these are true, then we do nothing. Otherwise, we go to error. Otherwise, if we have our flag size greater than 4, then we say that's not possible because we only have a limit of 4, and then we just go to error. So even though we already printed up a error here for saying if it's greater than 4, we also want to just let the user know like which one actually broke it so they can just fix it. So for local, it's the same thing. So we're going to start at local, meaning we need anything after this. So we're only going to have potentially one or two more items after local. So as you can see here, we have a flag size of 2, and it's pretty predictable. So we just check to see if the flag at 1, which is the one after local, is equal to this one or this one. Otherwise, if it's 3, then you guys get the point. So we have all of that, and that's it. So that's basically the entire function. Same thing for stable and extension. Pretty sure you guys can figure it out. You can just pause the video here and just kind of look at the code and kind of interpret what it's doing. It's pretty much the same. So let's go back to our compile function and go back to parsing enums or pre-processing them. So once we have everything set up for our access types, then we want to immediately add the extension access type. We don't want the user instantiating enum classes. After that, we have our class name. So our class name is going to ideally be the first token in our AST. And what we want to do is we want to check to see if the current class is generic. So we're going to say, we're going to get the current scope, we're going to get the class and check the type. And this is class generic, just checks to see if the bit at 1 is enabled. So if we look at the generic, where is it? So the generic is 2. So we're going to shift the bits 1 bit. So is class generic, so we're going to shift it over 1 bit and then inspect that bit to see if it's equal to 1. So we go back, if we have a generic class, then we want to get the enum class. And then after that, we want to check to see if the enum class is not equal to null and is at least pre-processed. And if it is at least pre-processed, we say the current scope, we add the class to the current scopes class, which is from the generic owner, and we return. Now, the reason why we want to do this is because if we have an enum class inside of a generic class, we want to pull that enum class basically that was pre-processed outside of that generic class, and we're getting the generic owner. So with generic classes, we're going to have a concept of generic owner, which is going to be basically the skeleton for that generic class, which is going to hold the basic information that we need to process it. So all we're doing is just adding the class that was found in the generic class skeleton into the current scopes class, and then we just return. And we don't need to process it because it's already processed. And after that, we basically want to, here's how we're going to actually create every single class in our programming language. So we're going to basically have a global class that we're going to create, and we're going to pass in the name of the class, any flags the AST was created in, and the classes. And that's going to return us a potential class. Now, if the current class is equal to null, that means that the user made a mistake. It's probably already defined somewhere else or something like that. So we just want to return out of this function. Otherwise, we generate the full name of the class by getting the current module and putting the hashtag and then the name of the class. Now, this is why we saw previously, even though technically the SRT Global owns this class, we're not going to do that inside of the full name because technically speaking, the global class is not known by the user. So we want the user to have a familiarity with, we don't want everything to be cryptic basically. So yeah, so we set the full name, and then we want to do the same thing for child classes. So we're just going to say add child class object. Now we haven't gone over this function, but you basically pass in a name of the class, the flags, the class owner, and the AST that's processed in. So this function is exactly like add global class with a few caveats. It does not have, we don't add it to the global scope class down here, but everything is the same. So we create our metadata like we always do. We create basically the subclass that we're going to be creating, and then we try to find that class based on the owner that we passed in. So we're going to look child class in that owner. Of course, we want to also check for our little crabby things here. I'm just going to call them crabby things because sometimes I forget the names of them. I'm never going to edit that out, but we have our less than and greater than symbol. And we also want to just do that check as well for generic classes. And if so, our standard, it's been previously defined error message. And this is also the same from adding global class objects as well. And then after that, we want to check to see if maybe the name that we passed in was already a generic name. If so, if it ends with these crabby things, we basically want to try to get the child class from there as well. After you do your final things, you want to set the AST, the owner, and you want to add this class to the owner since we've successfully been able to create it. Once we do all of that, go back. So once we have our child class, of course, if it's equal to null, we return because there's a potential that the user could have had a previous child class that was also of the same name. And yes, that also means that we will not process information inside of the class. If you guys are wondering, it makes sense to not do that because the user is just going to get weirder errors if we're defining things that aren't really supposed to be defined in the thing that it's defined in. So that's just a personal decision for me returning instead of like returning the previous object and then like processing it that way. So after that, we create our full name just like normal, and we also do a generic check here as well. So we basically check to see if the current class is a generic class. If so, we get the generic owner and we add this class to that generic owner. The reason why we want to do this is because we are going to be pre-processing a lot of information, and I actually think we call this function later on in the compiler when we're generating generic classes. So we just want to make sure we haven't processed this class more than once. We also want to set the full name by setting the generic owner's full name and then putting the dot and the current class. We also want to set the owner from the generic or as the generic owner. So after that, we basically set our current class and we set the processing stage equal to pre-processed. This is going to denote, now I don't use this everywhere. Like this whole set processing stage thing for classes, this is really only used for like pre-processing and post-processing generic classes. This, you're not going to see this used everywhere. So just keep that in mind if you guys are wondering why it's not plastered all over the place. After that, we want to add this current class to our enums list. So we're going to create a list of enums. It's just going to be easier for us to process enums this way instead of sifting through thousands of classes. So we have that list, and then we also want to set the address. Now, I know I said you don't want to set addresses in pre-processing. Classes are an exception. You can set addresses to classes at the pre-processing level. That's about all you want to do. You don't want to do anything else. You don't want to set fields or whatever. And then after that, we set the current class type equal to a class enum. And we create our scope. of class scope. This is going to be our next tier of scope processing. So we are now at the class scope. And then we want to basically set the current class that we just processed up here as the scope in question. And then all we're going to do is just for loop through our class. So we're just going to have a for loop here, and we're going to get the branch and check to see if like we haven't panicked or anything. And then we're just going to have a switch statement. Now, again, this is still pre-processing, so I am making sure that I'm not having any weird ASTs passing through. So I just ignore basically everything else, but I do keep all of these ASTs in here as types that I check for, because if there is a malformed AST structure, I want to know it at the front end. So after that, we remove the scope, and that's it for pretty much processing or pre-processing enum declarations. Now, the final thing we have to do though is we do have to process AST enum identifiers. All this is a enum var, and it's just a variable. It's just a field. So we're going to default all enum fields to a public static constant access flag. And that, I mean, it makes sense, right? If you have an enum, we're going to be accessing them. Enums in our language are going to be basically classes that hold values, and we'll see it later. Enums are a bit special in this language, but we'll see how we do it later. So you want to get the name, then you want to set up your metadata like normal, and this is the exact same code that I showed you guys when we pre-processed fields. All we do is just check to see if the field is literally in the class, and like I said, enums are fields at the end of the day, and we print our previously defined code, and otherwise we basically do our setup. So we have our field, and we pass in all of our information that we need. We set the type. Now here is where the whole enum fields are basically classes. This is how it's going to be represented. Enum fields in our language are going to be represented as the class of the enum it is encapsulated in. Meaning that if we have a class, or if we have an enum, where is the syntax file? Okay, so if I go here and I create an enum of color, right? Now I have this color enum and red, green, whatever, right? Don't need to put all of them, but these are going to be considered fields, and the types of these fields are going to be of the type of color. So as you saw, when we create the color enum, it's going to be a class. So effectively, this gets translated into class color, color, whatever, you guys get the point. So we're going to have our color class, and then we're going to have a field of red of type color. And literally that's it. And then we'll also have our green, which is also going to be of type color. And it's going to be a public static constant. And that way, you know, when we have these enums, because we're going to be setting values to them, right? So it's going to be equal to 1, 2, 3, whatever, that's going to be processed in a special way here. At the end of the day, though, this is still going to be a class. And when we actually do our setup, so when we assign values to our enums, this goes back to creating our standard library. It's going to start to get a little difficult with the language, and eventually we're going to have to start talking about how to build a standard library, because you cannot build a compiler without understanding how your standard library works. The reason why I'm able to write this code for enums is because I understand that I have this enum support class. And this enum support class is going to have the name of the enum. So for instance, if I wanted to print out the name of color.red, the way that I do that is I'm going to have to access this variable here to print that. If I want to access this value of color.red as 1, I'm going to access this ordinal int64 value. And that's going to represent the value of 1 that we're assigning here. So yeah, we have that. Also, of course, I have like helper functions. This class is still not finished yet. I still have to do some stuff to it, but yeah, just you guys want to kind of build your standard library as early as possible. So yeah, that's pretty much it. So that's how you pre-process enums in a programming language. So I know I talked briefly about like processing generics with enums, and I've been delaying it. I guess the next episode we'll talk about how to build the building blocks for our generic type system. So as a final thing before I go, there's something I want to mention to you guys. There are going to be certain things in this compiler that are kind of like gravitational pulls, or that's probably a bad way to put it. I'll just say that there's certain things in this compiler where the entire compiler revolves around that one thing. Generics are one of them. The entire makeup of how I compile everything in my programming language revolves around generic classes because generic classes are inherently extremely complicated. So before we get into the episode on Thursday or on Friday, I just want you guys to kind of keep that in your heads for that next episode and for the future. That all the things we're going to be seeing and what I'm doing and why I'm doing it is going to be in reference to the fact that I support generic classes. So that's going to be it for today, guys. As usual, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidevcd/sharp. And when you do, definitely watch, star, and fork this repository. That gives this language a lot more visibility and let other developers know this language exists. Also, if you guys are curious about learning what I do on a daily basis, you can check out the remastered branch. And I write some pretty wordy commits. Now, lately, they've been pretty simple, but you can kind of get a gist of what I've been doing without really having to look too much into the code. Some pretty interesting stuff has happened in the past few commits, so definitely recommend checking those out. I've been doing some testing with Linux because I'm now starting to do Linux testing on the programming language, and it's kind of annoying. So you're going to see a bunch of little blip commits here and there with just like one-liners. But yeah, also if you guys are curious about learning maybe some of the things that I've done in the past to the language or stuff that I'm looking to add in the future, you can head over to the docs folder and there's two main files. The change list is going to be everything that I've done in the past to the language as far as releases. The roadmap file contains all of that information as well as new stuff that I'm looking to add in the future. So hope everyone enjoyed the video. As usual, if you guys are new to the channel, definitely consider subscribing, and until next time, I'll see you guys later.